Hi, this is Darwin Olseny. Today I will be doing the video explainer for week 3 of Physics 251. Problems 30 and 39. Problem 30. You go to an amusement park with your friend Betty, who wants to ride the 30-meter diameter Ferris wheel. She starts the ride at the lowest point of the wheel that, as you face it, turns counterclockwise. What's her displacement vector when the wheel has rotated by 60 degrees? Give your answer as a magnitude and a direction. The first thing I like to do is write down the givens. In this situation, we are given the diameter of 30 meters and the displacement of 60 degrees. So this is a picture of the Ferris wheel. I'm assuming that the origin point is in the middle of the Ferris wheel. So another thing I'm assuming at this point is that the Ferris wheel only has a radius of 1 meter. I'm doing this to simplify my calculations. Okay, the next thing I want to do is find out the coordinates of the point where Betty is on the Ferris wheel. In order to do this, I need to find the amount of degrees off of the x-axis that she is at this point. Using my knowledge of the unit circle, I know that if she's 60 degrees from the base of the circle, then she must be 210 degrees from the right side of the circle, where the x-axis meets the circle. Now that I know this, I can take the cosine of 210 degrees to find the x coordinate, which is negative square root of 3 over 2, and sine of 210 degrees to find the y coordinate, which is negative 1/2. Now that I know the starting point coordinates and the final point coordinates, I can find the displacement between them by subtracting first my final y value from my original y value, giving me a result of 0.5, and then taking my final x value and subtracting it from my original x value, giving me a result of negative 0.866. Okay, so if you remember from before, I had assumed this Ferris wheel to have a radius of only 1 meter. However, the actual Ferris wheel has a radius of 15 meters, which I got from dividing the diameter by 2. So, in order to convert these values I got from the 1 meter Ferris wheel into the 15 meter Ferris wheel, I'll just multiply them by 15. So, for my y, my change in y, I get a value of 7.5 meters, and for my value of change in x, I get negative 13 meters. Now I can use Pythagorean's theorem to find the magnitude of my vector, which I am labeling as A. So I get that to be 15 meters. Now I want to find the angle inside this triangle, because I'm going to use this to find the direction of my vector. I do this by taking the inverse tangent of my opposite, my y component, over my adjacent, which is my x component, and I get a result of 30 degrees. Finally, in order to find my direction of vector A, I'll take the angle on top of this line, which is parallel to the x-axis, which is 180 degrees, and I'll subtract from it the angle that I had within the triangle, made up of my x component, my y component, and my vector, which was 30 degrees, and I will get a result of 150 degrees. So my final answer is the vector A has magnitude of 15 meters and is directed 150 degrees off the x-axis. Question 39. Tom is climbing a 3-meter long ladder that leans against a vertical wall, contacting the wall 2.5 meters above the ground. His weight of 680 newtons is a vector pointing directly downward. Weight measured in newtons is abbreviated N. What are the components of Tom's weight, parallel and perpendicular to the ladder? Okay, the first thing I'm going to do is write down the length and height on the wall. The length of the ladder is equal to 3 meters, and the height on the wall is equal to 2.5 meters. To make this problem easier, I'm going to tilt the x and y axis so the y axis is parallel and the x axis is perpendicular to the latter. Then I'm going to want to find the angle at which, from the y axis, that Tom's weight is pointing. In order to do this, I will take the adjacent, which is 2.5, which I get from the height on wall, and divide it by the hypotenuse, which is the length of the ladder. So the inverse cosine of this gives me a result of 33.6 degrees. Now I want to find the x and y components of Tom's weight vector. So they're going to create a triangle in combination with the vector here. And I can use this in combination with trigonometry to find each of their individual values. I know the angle that the hypotenuse of this triangle, the vector, is off of the y-axis. So I can use this angle to find the x component by taking sine of the angle and multiplying it by the magnitude. This gives me a result for x of 376 newtons. Looking at the graph, we can tell that the x is facing in the positive direction. So I have the final answer written as 376 newtons. Now, for the y component, I need to take the cosine of this angle, 33.6 degrees, and multiply it by 680, which is the magnitude of the vector, to get 566 newtons as the value for magnitude of the y component. But as we can see in our picture, the y component is facing in a downward direction. So I have the final answer for the y component as negative 566 newtons.